I'll show you how to quickly make a simplified Ionic style Greek column for this tutorial. You can find a reference photo online for whatever type of column you wish to make and import it into Blender using an empty. This allows you to be in X-ray or wireframe mode and still see the reference image. After I imported the reference image, I add a circle with 32 vertices and move it into position at the bottom of the fluted part of the column. I scale it to fit the reference image. In edit mode, I select every other vertex and then scale them in towards the center. I then use Shift-Control-B to add a small bevel to these vertices. I select all the vertices and extrude them up along the Z-axis to match the reference. In Object mode, I select the column, right-click, and choose Shade Smooth. Then under the Object Data Properties tab, under the Normals panel, I activate Auto Smooth to fix any shading issues. I add a second circle for the bottom of the column, scaling and extruding it in edit mode. On the top and bottom of the circle, I select opposite edges and fill in the faces. In Object mode, I select the column, right-click, and choose Shade Smooth. I activate Auto Smooth to fix any of the shading issues. I now add a cube for the very bottom of the column. Scaling it to size in edit mode. I can then inset the top face for the middle section, extruding that inset face up along the Z-axis. And then I repeat this step for the upper part of the base. For the capital, I duplicate the circle from the base and place it on top of the fluted column, scaling it to the proper size. I then add a cube for the top of the column. And use the same technique I used for the bottom to finish off the upper part of the column. I hide everything except for the reference. You'll need to have the Add Curve Extra Objects add-on activated to follow along with this part of the tutorial. For the capital on the top, I add an Archimedean spiral with 2 turns and a smaller radius and a larger radius growth. I rotate it around the x-axis by 90 degrees and place it on the capital spiral. I then extrude and move the vertices to follow the spiral of the reference, stopping when I reach the center of the column along the x-axis. Under the Object Data Properties tab, under the Geometry panel, I add a bevel to the curve. I then add a mirror modifier along the X and Y axes. I can use clipping to make sure the 2 sides meet in the middle of the x-axis. In Object Mode, I right-click on the curve and convert it to a mesh. This will also apply the mirror modifier. In Edit Mode, I scale the curves along the y-axis and then move them into place. I select the interface loops of the spirals, right-click, and choose Bridge Faces. I select the open edge loops in the center and merge the vertices in the center. Now to add more thickness, I use Alt-E to extrude the faces along their normals. I then add a subdivision surface modifier to smooth the edges. I select each part of the column, and in edit mode, I add a small bevel. Now, for the materials, I select every object and use Ctrl-J to join everything together. I then use Ctrl-A to apply all the transforms. This will help with the unwrapping in the materials. I split the viewport and open the shader editor and the UV editor. In edit mode, I select the column and using the U key to open the UV mapping options. I'll use cube projection for this project. In the UV editor, I select all of the islands, and under the UV menu, I average the island scales. I then use the Pack Islands option under the UV menu with a small amount of margin for a bleed area around the islands. I'll be using a technique to make a marble material that I learned from Ducky 3D. I add a Voronoi texture and a color ramp. Connecting the distance of the Voronoi texture to the color ramp and the color ramp to the base color of the principled shader. With the Node Wrangler add-on activated, I select the Voronoi texture and use Ctrl-T to add mapping and texture coordinate nodes. I change the connection of the texture coordinate node from generated to object. On the Voronoi texture, I change the distance to edge. I also changed the scale on the Voronoi texture. And I moved the white color stop on the color ramp to the left. Between the texture coordinate node and the mapping node, I add a noise texture and a mix RGB node. I connect the texture coordinate node to the bottom input of the mix RGB node. I can now change the factor of the mix RGB node. I duplicate the mix RGB and noise texture nodes. I place the second mix RGB node between the color ramp and the principled shader. I then connect the mapping node to the second noise texture. I duplicate the color ramp and connect the second noise texture to it, adjusting the color stops. If I change the factor of the second mix RGB, I can change the darkness of the original material. To add some sheen to the marble, I duplicate the noise texture and color ramp. I connect the mapping node to the third noise texture. I then connect the factor of the noise texture to the color ramp. I connect the color ramp to the roughness of the principled shader. Now if I move the black color stop to the right, I can dampen the roughness and see some sheen on the material. I can also adjust the roughness on the noise texture. I also changed the black color stop into a dark gray and the white color stop into a light gray. For the bumpiness of the material, I add a color ramp and a bump node. I connect the third noise texture to the fourth color ramp. I connect the color ramp to the height of the bump node and the bump node to the normal of the principled shader. I can now change the strength of the bump node. If you want to change the color of the marble, add a color ramp between the mix RGB and the principled shader. This will allow you to control the color of the material.